What's up, everybody? In this video, we're going to be learning how to do 2D prefix sums. This video is going to assume a little bit of familiarity with 1D prefix sums. So if you're not familiar with those, it might be a good idea to brush up on them before watching this video. So first obvious question is, what is a 2D prefix sum and when would you want to use one? So in a problem, say like you have a grid, like the one I have on the left here, and you're needing to analyze something about the grid that requires you to be able to get the sum of a certain subset of the grid in a short period of time. Now, ordinarily, if I needed to add up all these numbers, I'd have to do 4 plus 2 plus 0 plus 1 plus 2 plus 1. And if we're going to be repeatedly querying this grid, rather than having to re-add those numbers every single time, essentially what a 2D prefix sum is going to do is the same thing that a 1D prefix sum does for a 1D array, except it'll be doing it for a box rather than doing it for just a subset of an array. So the way this is going to work at a high level is essentially what we're going to do is we're going to be figuring out the sum of all of the numbers within a certain box starting from the top left. And we're always going to be going from the top left and filling that in the grid on the right. So the grid on the right here, as you can see, is one size 1 larger in each dimension in terms of the number of rows and number of columns. And what this corresponds to is this grid right here, which is a 4x4, corresponds to this 4x4 space right here, essentially. And then in each square of this 4x4 grid on the right, or 5x5 grid on the right, we're going to fill in the sum of all the numbers that are above and to the left of a particular target. So what that means is in this square right here, this is 1, that corresponds with this right here. In this spot right next to it, we're actually going to put a 3. And that 3 corresponds to the sum of the 1 and the 2 that's directly next to it. Oops, I erased my grid. The 1 and the 2 that's directly next to it. So that 3 is 1 plus 2. It's everything from this square that is above and to the left of it. For this one down here, we're going to put a 4, which is the 3 plus the 1. So that's a 4. And for the final square here, we're going to put the sum of all of them in that 2x2 grid. 1 plus 2, whoops. 1 plus 2 plus 3 plus 4, which is going to be 10. Okay, so that's your initial setup, essentially. And then what that's going to allow us to do is very quickly analyze whether or not, oops, I'm in trouble with these lines here, very quickly analyze what the sum is in a certain area. These lines are giving me trouble. Let's see here. Try that back. Okay, so the way we're going to fill this grid out is for any given space on the grid, we're going to take the number that's above it and the number to the left of it and add those together, and then subtract the one that's up and left from a diagonal. So let's walk through what that means. For this square right here, the way I did that initially when we were just kind of freehanding it is I added those 3 numbers together, or those 4 numbers together. I got 1 plus 2 plus 3 plus 4. That gave me a total of 10. Now what that 10 represents is if I were to look at this 3, that 3 is the sum of this 1 and this 2. And this 4 here is the sum of the 1 and the 3. And if I were to add the 4 and the 3 together with the number that's right here, 4 plus the 1 plus 2, which is, again, this 3 up here, plus the 1 plus 3, then essentially what I've got here is I've got a total. Now this total equals 11. And the reason why is because this 1 has been included in the total twice. When I did the 3 here, that corresponded to the 1 and the 2. The 4 here corresponds to the 1 and the 3. And when I add those together with the 4 here, I've covered all the squares except the top left got included twice. And you can see that here with this plus 1 here and this plus 1 here. So in order to counteract that, we know that this spot right here corresponds to what's up and left from there, which is that 1. And we can subtract that back out. And that's going to give us a total of 10, which is our expected total. So to kind of recap that, essentially what we do is we fill up this grid. Let me clean this up here, just clean this up. Okay. So essentially what we're doing is we fill in the grid is for any given square, we look at the number that's above, the number that's to the left, and we subtract the one that's diagonal from it. So for here, right here, oops, let me switch colors back to blue. For this one right here, we're going to do the number above, which is a 0, the number to the left, which is a 0, subtract the one that's up and left from it, which is a 0. Those are all zeros because we're on the border. And then add the value of the one that's in that square, which in this case is just going to be a 1. And we'll continue to fill the grid out in that fashion. So this will be a 1. The top here is going to then be a 3. 3 plus 0 is still going to be 3. and then plus 4 is going to be 7. And this actually kind of, the first row fills out sort of similar to a one-dimensional prefix sum. Let's get on to the next line here. This is going to be a 4 because again, that represents this 1 plus this 3. And the way we got that is we did the 3 here plus the one above it plus the one to the left of it minus the diagonal, which is just 4. And these diagonals will make a little more sense once we get a little more kind of into the middle of where the data is. Okay, so this square right here, again, to recap, the one above, this 3 right here, represents the 1 and the 2. The 4 to the left represents the 1 and the 3. We're going to add those together and subtract the 1 that's diagonal here, which represents this one in this corner. And that's going to give us a value of 10. So we'll go ahead and fill out a 10 there. 10. This one here is going to be the 2. It's already there. Plus 3, plus 10, minus 3. Let's look at what that represents. So I got 13 minus 3, 10 and 12. So let's again recap where we get the number. This 3 right here represents the sum of these guys. This 10 right here represents the sum of those. And so what we've done is we've done the 1 plus 2 plus 0, and then the 1 plus 2 plus 3 plus 4. The 1 plus 2 has gotten added in twice. This 3 here, if you remember, represented that 1 and that 2. So because that 1 and 2 got added in twice, when we subtract that 3, that's going to be removing that double add right there. And that pattern will work all the way through the grid. So let's go ahead and I'm going to clean up this math problem on the bottom here. We'll fill out the rest of this grid. Let me see here. Red, blue. Okay. So this one right here is going to be the 2 plus 12 plus 7, which is going to be 14, 21 minus 3, which is going to be 18. Down here on the next line, I've got 4 plus 0 plus 3, which is going to be 7. Next to that, I have 0, which is what's in this block right here, plus 10 plus 7, the 10 and the 7, minus the 4, which is going to be 13. For this one here, I've got 13 and 12, which is 25, minus 10, which is 15, plus the 1 that was already there, which would be 16. In this final grid here, I've got 18 plus 16, 18 plus 16, minus 12, plus the 4 that was already in there. And just to, I'm going to redraw these and show you where this comes from again. So this 18 here above represents this entire top section. That's the sum of everything in that square. This 16 right here represents everything in this section right here. So you can see that I've done the 1 plus 2 plus 0 plus 3 plus 4 plus 2. That's happened twice. The first time with this top box, it was included. The second time with this 3 by 3 grid over here, it was included. So I need to subtract that out, and that is represented by this 12 here. So by subtracting out that 12, I'm removing the extra one that got added. And so just to kind of highlight that, the first chunk that's getting added is here, minus the ones to the left. If you were to subtract out of the first one. So that's 18 minus 12, which is 6. And that's basically this whole thing minus the thing right next to it, which leaves the 4 and the 2. And then we're adding in the 16, which represents this entire 3 by 3 grid. That's where that 16 corresponds to. So you can see I've got all those elements except for the 4, and then the 4 is the last thing that has to get added in. And that gives me the sum of all that space right there. Which, back out of this, okay, so that gives us a total of 26. 26. Let me clear this. Bottom row is going to be 7, 15, 19, and 32. Go ahead and do the 32 for you. The 26 here represents this entire top section. The 19 here represents this left section. You can see that top 3 by 3 grid got added twice. So by subtracting the 16, we're removing one of those top grids. So then we only have that one time together with the ones that are left over here, here, and then the 3 at the very bottom. And that's where we got the 32. Just to kind of demonstrate the algebra there. I've got 26 plus 19 minus 16, and then plus the 3 that was already in that box. So 26 minus 16 is 10, plus 19 is 29, and then plus 3 is 32. Okay, so now that we've got that grid filled in, essentially what this tells us, and just to kind of go over this again, every single square will tell us the sum of everything that's up and to the left of it. So this 13, for example, if you consider this to be the 4 by 4 grid with 4 rows and 4 columns, this is the third row and the second column. The third row and second column corresponds to that 0 right there. That 13 represents everything that's above and to the left of that, this grid right here, which is 1 plus 2 plus 3 plus 4 plus 3 plus 0, which is 3 and 3 is 6, plus 4 is 10, plus 1 and 2 makes 13. So now that we have that, that brings us to the next step, which is how do I use this information to find the area or find the sum within some certain sub box. Oops, let me see if I can erase that without losing the grid. I don't think I can. I'll just redraw that real quick. Okay. Okay, and then that was 13. Okay, so how to use this to find a subgrid. So in the very beginning, I was saying we can use this to find the area, or not the area, the sum of a subgrid. So let's use the same subgrid here. So if I wanted to find the area here, what I have to work with is I've got the 19, which corresponds to, let me see here, switch back to blue. I've got this 19 here, which corresponds to everything in this whole top section. That's the sum of all the numbers above it. What I want to subtract out then is going to be these numbers here, which we can find in this box right here. And then these numbers over here, which I will find in this box down here. So let's look at kind of how that works. I've got my 2 by 2 grid that I'm trying to solve. Let's see, was that from the 19? Yeah. So from the 19, I'm trying to find the area in this middle section right here. I'm going to draw it on the other side as well, so I don't have to look back and forth. Trying to find this area right here. In order to do that, I think I went too far. Yeah, actually, it should have been the 7, not the 0. Let me fix that real quick. Oops. One more time. Come on. The pen is skipping. There we go. All right. All right, so trying to find the area in this subgrid right here. So what we're going to do is we have the 19, which represents the entire top section. If I were to circle this entire top 4 by 3, that's what that 19 represents. What I want to subtract out then is the area on the left, this 133, which is represented by the 7 here. The top section, the 120, which is represented by the 3 right here. But if I subtract both the left section and the top section out, just like when we were generating it, you'll notice that top left got subtracted out twice. So I need to add that back in, and that's represented by this one right here. So finding the area inside that box is going to be 19 minus 3, which is going to subtract out this top section, minus 7, which subtracts out the left section, but then plus 1 to add this top corner, which has been subtracted twice. 19 minus 3 minus 7 plus 1 is going to give me 10. And if I do 4 plus 2, that's 6, plus 1 plus 1 is 8, plus 2 is 10. Let's go ahead and do that with a couple more of these. Back way out. Subgrid. Okay. There. Okay. We'll do one more. Let's say like I want to find the area in this bottom 2 by 2 grid right here. So that's represented by this right here. I've got 32, which represents the sum of the entire thing. I want to subtract out the 18, which represents this top section. I want to subtract out the 15, which represents the left section. And then I want to add back in the 10, which represents this top 2 by 2. So 32 minus 18 minus 15 plus 10 is going to give us, let's see, 32 minus 18 is that 14? 14 minus 15 would be -1 plus 10 equals 9. And if I do 4 plus 3 plus 1 plus 1, I have 4, 5, 6, 7, 8, and 9. So that's 9. So let me clear this back out. So just as a real quick recap, essentially what you want to do is using your 2 by 2 or your grid here, which is larger in one dimension, whatever your subgrid is that you want to solve. Let's just redo this last one that I just did. Let's actually do a 1 by 1. Let's do a tiny one just to show that this actually will work for any dimensions. If I want to find this right here, then that maps to this location right here. I would do 16 minus 12 minus 13 plus 10. 16 minus 12 minus 13 plus 10. 16 and 13 are going to cancel out, leaving me with 3. 3 and negative 12 is going to leave me with negative 9. Negative 9 and 10 is going to be 1. And that is what goes in that box. So basically what you're doing is whatever your box is that you're trying to find the subset of. I'm going to draw a larger one. So let's do this area right here. All right, let's do the middle. Whatever your area is that you're trying to find the sum of, first thing you do is you take this number right here, which is your bottom right corner of your grid. That's this right here. Then you want to move to one step above your grid. That's represented by the 0 right here, this 3 right here. Whatever's outside to the top, you subtract that number out from your subset, from your prefix sum. Whatever is to the left of your grid, you subtract that number out. That's the 7 right here. And then whatever's up and left from the diagonal of your grid, you're subtracting that out here. So by taking this 2 by 2 spot right here on the left side, that 2 by 2, in order to sum those up, we get the sum of the whole entire top grid minus the top row, minus the left row, and then adding in whatever got subtracted out twice, however large that happens to be. So just as a real quick recap from the top, filling out your grid, when you want to know what goes in a particular spot, for example, this spot right here, you do the number above, add it to the number at the left, add it to whatever's in that box, which in this case was a 0, and then subtract the top. When you want to, and that's for filling out the grid initially. When you want to find the area of whatever's inside the grid, I think it was a 13. Whenever you want to find the area what's inside of a grid, you get the number here, minus the one that's outside to the top, however far that might be, minus the one that's outside to the left, and then plus the one that's outside to the diagonal. In that case, that would give me the area of this box right here, which corresponds to this box right here. So that's a 2D prefix sum. Hopefully this is helpful for you, and talk to you on the next video.